to today's webinar, latest in our series of Ship Management International industry webinars, and we're delighted to be hosting it today in conjunction with Stream Marine Technical. I'm just waiting for some of the delegates to come in, and they will be, as they normally do, come in different levels and what have you. Just really on a bit of a housekeeping, today's webinar should last about an hour. There you'll see, to the delegates, you'll see at the bottom there's a Q&A section down there, and also a chat facility. Probably ask you to focus a bit more on the Q&A, because that means that everybody can then see the questions that you're putting forward, and then I will do my best to make sure that the panelists also get an opportunity to answer those as well. The webinar today is being video recorded, and it will be edited and made to look very, very nice and pretty, and then it will be sent on the SMI website and also sent out to the panelists as well. So you'll all be able to view it as well, or download it at your leisure. If you just go on to, in about 3 or 4 days time, maybe a week's time, go on to shipmanagementinternational.com. You'll see the webinar there, and then you'll be able to share that also with your work colleagues. And we will be covering a lot of areas here. We've got some good presentations, so it's well worth listening to yourselves, as well as getting your colleagues to listen in as well. Really, without any further ado, I'm going to ask, well, just to say that today's webinar, we're looking at the IGF training, Meet the Molecule, and looking at methanol. And it will focus on an introduction to methanol as an alternative fuel in maritime. And a panel of experts will discuss the benefits of methanol as a marine fuel, how it can meet decarbonisation goals, and industry trends towards the use of methanol as a fuel. I'm going to ask the panelists just to introduce themselves and to give a little bit of a 2-minute policy statement on their views on the whole issue of methanol and the opportunities and challenges ahead. Then we'll then go into a couple of presentations, and then there'll be some questions. But as I said to you all, please whiz over some questions on the Q&A, and then we'll then all be able to answer those. As I said, we should be finished by about in an hour's time or so. Kjeld, can I start with you, sir? And nice to see you, and thank you for coming along today. Could you introduce yourself, tell the audience where you're from, and also just give us your sort of snapshot views, and then I'll come on to Ian and Craig. But over to you, sir.
Yeah, thank you very much, Sean. And thank you for the invitation to speak. My name is Kjeld Aabo, and I have been working for MAN Energy Solutions with two-stroke engines for 40 years. I retired from MAN 2 years ago, and I started as a senior advisor for Methanol Institute. I've actually worked with Methanol Institute to MAN for many years, since the first two-stroke engine was coming out at sea trial. What I would like to present today, and is our political view, is that methanol will be one of the important fuels for marine in the future. It will take a long time. The decarbonization, there need to be built, production, logistics, and all that, and that's some of the things I will come into. But the important part for us now is to have the regulations in order and to have patience, investments in new projects, and so on. Thank you.
Brilliant, Kjeld. Thank you. Just getting myself off mute there. That's like some good points there, and I think really that whole issue of the regulations and the infrastructure, I think, is something that we'll maybe focus on a little bit as well as the discussion goes forward. Ian, can I come to you just for you to introduce yourself, and then if you can then get Craig to also do the same, but very much on the same vein that Kjeld has just done now. Over to you, Ian.
Sure, thanks. Yeah, my name's Iain Bonehill. I'm one of the technical trainers at Stream Marine Training. We do IGF courses, among other things, and obviously methanol familiarization. My background is as a marine engineer on various types of ship, predominantly LNG tankers, so carrying LNG as a cargo, and latterly working in the training industry, delivering industry courses, STCW courses, and familiarization courses. As far as methanol goes as a fuel, I agree with Kjeld. It's definitely one of the main topics of the future, and its major benefits are going to be that it is the most familiar of the alternate fuels because it can be stored as a liquid. One of the major challenges is going to be the supply of specifically green methanol, which we need. we can't really use the current methanol from the chemical industry because that's made from fossil fuels, which doesn't really meet our environmental and CO2 emission goals. So it's going to be an interesting few years developing the infrastructure to produce and supply green methanol to both the maritime and other industries. So a very interesting coming few years, let's say.
Brilliant. Thank you, Ian. Passing over to you, Craig.
Yep. Hello, my name's Craig Smith. Again, I'm one of the technical instructors here at Stream Marine Training, or Stream Marine Technical.
Would you just speak up a little bit, Craig?
Yep, I'm one of the instructors here at Stream Marine Technical. My background as engineer for many years, mainly oil tankers and offshore types of vessels, before becoming superintendent vessel manager for, again, different types of tankers, predominantly oil tankers, LPG and LNG. Over here at Stream Marine, as Ian says, we do the technical side of IGF training, bespoke courses for other things as well. And yeah, as for methanol, it's not much more to say. It is one of the future fuels. With LNG being the transitioning side, we now need to look at the other side as well with future fuels. Technical difficulties on ships, technical difficulties port authorities have to deal with as well. All that comes through the future.
And I think some valid points there. If there's one thing that's certain in shipping at the moment is the uncertainty about fuels for the future. One size won't fit all. There's going to be a lot of discussion, a lot of debate moving forward. So it's going to be a very, very interesting time in the next 3 or 4 years, without a doubt. Okay, just to remind the participants who's starting to creep in, which is good. You've got the Q&A down the bottom. You've got experts here who are very, very tuned to the whole issues of methanol as an alternative fuel. Please send us your questions, and that's good. But I think we've already got, maybe somebody has raised a hand, but if you can actually send in, just put in a Q&A, question on the Q&A, then I'll pick it up. Okay, so we're going to go into our first presentation. I'm going to ask Kjeld if you can then share your screen and then go through in your presentation. Participants, please send any questions you have through as well. Over to you, Kjeld.
Okay, thank you very much, John. My presentation is an introduction to methanol as an alternative fuel in maritime. I will talk about what we are doing in Methanol Institute and how we see the market right now, and what we see of challenges and the pathway all the way to the end goal in 2050, you could say, or at least that is one part of the goal. Boom. I'm very fast here. See, just a little bit of history. Methanol Institute started and was established in 1989. It's a trade organization for the global methanol industry, facilitate methanol increased adoption for from MI offices, and you can see it's Brussels, Washington, Delhi, and it's Beijing, and it's also Singapore. Connecting the value chain, informing and educating about methanol and safe handling of methanol. See, we have to remember that the methanol produced today is used in the industry. It's about, now these figures are for 2023, but about 100 million tons of methanol is used today for the purposes, as you see on the right here, like formaldehyde, acetic acid, it's DME, MTO, fuel apps, biodiesel, and so forth. And this is amount of methanol that still are to be used, and in the end also have to be decarbonized, you can say, or carbon neutral. But if you look at the left side, today the methanol is based on natural gas and coal as feedstock, you could say, and this have to, of course, change if we are going to be CO2. This is the member list of the members of Methanol Institute. We have split it up in 4 different groups. There is the producers, some of the biggest in the world. We have the maritime part as row number 2, you could see, and they are coming in basically after Maersk announced that they were going to use methanol engines on their container vessels. Suddenly the interest for the maritime was exploding, you could say, and a lot of members there are from that area, the maritime. Then we have renewables. I was just 2 weeks, 1 month ago at Kasø in Denmark, where a e-methanol plant was introduced. It's a small plant, you could say, but quite big worldwide when we talk about the startups, pilot projects, and so on. Cubic meter of tons per year they are producing. They have gone together with Maersk Mc-Kinney Møller, and they have gone together with Lego, and also with medical industry in Denmark, Novo Nordisk, as they will take off the production produced e-methanol, where they are actually collecting the CO2 from the biofuel production. So quite an interesting project coming up now, and they are actually extending it. So things are really happening. That will also be shown later on in my presentation. Then there are the companies going for renewables, as we talked about here, and we have the technology providers also. If you look into the market and the OEMs, their intention for the design of future engines, you will see that already a lot of OEMs have engines burning methanol in their portfolio. It goes from 100 kilowatt up to 82 megawatt on one engine. So it's both propulsion engines, it's also gensets, and it's all what you use of engines in aboard vessels. So there is, you can say, no challenges there when it comes to the engine and choose of engine for a methanol. Also, like mentioned just before, that a lot of running hours have actually already been gone on two-stroke engines from 2016, where the first two-stroke engine was at sea trial. The year before, actually, Wärtsilä had a four-stroke engine on Stena starting up on sea trial. It was a retrofit project and so on. So the experience on using methanol is, you can say, a long list. It can be carbon neutral. It's easiest to storage. You don't have the cryogenic systems. It's simple fuel gas supply system. And from my time in MAN, we went through a lot of hazard investigations along with the design and the development of the engine itself. Just to be totally safe. It is a low flashpoint fuel and has to be treated like it. We are following closely what is happening on the engine side. This is new vessels and orders with methanol engines, propulsion engines. About 378 vessels have been ordered yet, and it's increasing every month. If you look at the top in the middle here, you will see the engine models. You will see different bore sizes, like 95 centimeter. You have the 50 bore, and you have also coming up some of the a little bit smaller ones. We look at the at the OEMs. It's MAN, it's VinGG, and it's Wärtsilä, it's ABC. And if you look at the application and vessel types, you see it's all from container vessels to offshore. It's ferry in between ro-ro, it's oil product tankers, and so forth. And a long list here on the right side of the companies who have actually ordered such vessels. This is the ready new vessels and ready book. 753 is registered, and this is vessels that accept that actually from the beginning when ordered have the opportunity to be retrofitted later on. It's you can say it's exactly the same engine they have from the beginning. There is no prepare of the engine on the engine itself, but they prepare the vessel like having space enough for fuel gas supply systems and tanks, and also having reinforced the places on the vessel so it's not necessary to do when it's going to be retrofitted. Of course, that will take a long time, and the engines are in operation, you can say, in service. So to reduce that time is important, but also the cost for it is important. If you look at the auxiliary engines, about 180 ships are ordered with auxiliary engines that can operate on methanol, about 712 engines totally, and the designer of that is, you can see, Himsen HHI, which also was the first one for the container vessels for AP Møller Maersk, and they had quite some orders there in the beginning. So a lot of engines out there, and on the way being produced. We have a MAN, we have Vertila, and then there is some unknown which Clarksons have not registered. But also very interesting is that there is about 50 vessels or more which is ordered, big container vessels from very known big operators like AP Møller Mærsk, CMA CGM, Seaspan, and COSCO, container vessels having huge impact on the CO2 savings, you could say, and quite a number of these vessels. And we believe that a lot of those engines here, which is in service already, will be retrofitted in the future. There is a lot of those engines which still are operating, still have a long lifetime, which can be converted. So depending on when you can say the green methanol is available, there will be much more. We made, and that was when I was in MAN, we made actually a small study just to see what is the price difference if you have a LNG fueled vessel or a methanol fueled vessels or just a normal, you can say single fuel engine with fuel oil. And it was done together with Hyundai Mipo, DNV, and us and Methanol Institute. And if you consider this price of the vessels being 100, then 110 will be the factor, then 10% more will be if it's a methanol fuel engine, and about 22 if it's an LNG fuel engines. That will of course change if you go up in size of the engines, because this cost will be relatively smaller and so on, but there will still be a somewhat higher price for the Guinea systems. One of the areas where we are working very intensively, both with authorities and suppliers and regulators and so on, is the green corridor. We have an expectation that green corridors can actually accelerate the decarbonization, because here you take pilot projects, you make pilot projects in an isolated situation where, for instance, if you take Rotterdam, Singapore, where we have been members for more than 2 years, you see suppliers of methanol, the harbor authorities, and all these are going together, sitting in groups and finding out how can we make a solution, finding out what is the safety aspects here, how is the bunkering procedures, and how can we get the methanol, and how to arrange, you can say, the supply and bunkering of methanol in the harbor. A lot of things is looked at here, and that means salt for not only this green corridor, but in the end also salt for the whole world, where methanol is going to be used as one of the fuels. We are also a member of Nordic Roadmap. We are member of Silk Alliance, which is a Lloyd's register working out of Singapore. And you can say the status right now is that the vessel is found and it has to be, the engine have to be retrofitted for methanol and looking at all the other aspects I mentioned before. There's Lingang pilot, that is on the west coast of United States, Canada, up to, you can say, Alaska, where there are some routes. We are also looking at green corridors, but also from west coast to Japan and west coast to Korea and so on. So a lot of that is going on. Actually, there are about 62 registered green corridors in the world right now. It's easy bunkering. You can say there is opportunity with chemical tankers, older smaller chemical tankers you can use actually for bunkering the methanol. It's by far easier than having the cryogenic systems and supply and so on. So it will not take as long time as it has for the LNG to be introduced to the whole world. It will go much faster. There is, of course, it's not only when we call about CO2 neutrality for green methanol, there is also the advantage of the SOx reduction, the particulates, and the NOx. The NOx is to be taken with a kind of salt, because what the OEMs to do is actually to, because it's from nature, when you're burning methanol, have a lower NOx level in the process, in the combustion chamber, then you actually fuel optimize the engine, so it have actually a better fuel oil consumption than a normal fuel oil burning engine or any of the other, you can say, dual fuels that is on the market today. So both MAN and WinGD, they have their methanol engines have the lowest fuel oil consumption of all their engines. We work with different partners on the marine side. We are NGOs. We became that 1 year ago for IMO and I have been participated with colleagues in MEPC 82 and 83. And of course, also we're going there in 84. What we are there for is to look at, do anybody actually know what methanol is for the marine market? What is important to look at for the application of methanol? And here IMO is also safety included, but there's of course also the political part. And here we work to flag states as any other NGO have to do. Then we have clean maritime fuel platforms, European Sustainable Shipping Forum, and Renewable and Low Carbon Fuel Values Chain Alliance. We have been part of ISO 6583, which is issued here last year, end of last year. We have been part of FGMF. We have made a safety and operational guideline for bunkering. It is actually issued already. This is because it's a picture of an older picture and so on. We have made a methanol fuel calculator at our website just to have an impression about how much methanol is actually needed. This is a very good tool we use for the green corridors, where they are finding out what is actually necessary to actually incalculate in the needed production supply of the green methanol to the harbor. We have made different guidelines in the time and together with different partners also. I know you will have the presentation, so here you will also be seeing what we can do. There's, for instance, guideline for truck to ship, shore to ship, ship to ship. And there will be more bunker handling guidelines because this is a continuous process and we learn more and more from the vessels in service. And of course, that will also be taken into account. Then there's also the education, but I'm sure you will hear from my panel colleagues here more about the education itself. See, if you look at the production of the pipeline for the new fuels, you will see here in 29, you will have North America, you will have China being 46, you will have Europe, and you will have the rest of the world, which will be the renewable methanol capacity by region. So you see China is very much, and actually totally, they are today, I think it's about 66% they are producing, or at least 66% are they utilizing of the methanol produced today, and about the same is also what they produce themselves. Goldwind and Maersk, Goldwind have made some commitments to Maersk about supply of methanol. So this is also going the right way because there's no secret. There is no really a lot and definitely not enough of the green methanol today. But it is a process. We need to have patience, as I mentioned before. We need also to have a regulation that can push for the production, investment in production, logistic, and so on to come on. And it will, of course, go that way as we see it. In today availability, there is about 120 harbors today where methanol is treated. But that's the methanol used today already by the chemical industry and as I mentioned before. But there is about 16 harbors where they already have bunkering possibilities for vessels coming in. And there are 22 harbors where they are now investing and installing in bunker facilities. I'm not so much into looking in a crystal ball because it changes from time to time. And of course, this is a prediction. If this is going to be the case in 2050, really don't know. And I don't believe that will be the case, to be quite honest. A lot of things will change in that. But we hope that this is the way it goes, because this is the target for the world and the CO2 limitations and so on. There is also another thing to be mentioned. I would say, and that is that maritime is very much in front of the sectors if you compare to aviations, for instance, or individual countries, industries, and regulation, and so on. It's maritime have gone together, and now, hopefully in October, in MEPC 84, there will be some conclusion and acceptance of the new proposal from 83, which I find really going in the right direction. But there will be different fuels out there. I have no belief that methanol can take the fuel supply. That would be unrealistic, we think. But there's also other industries that on the way in the decarbonization will start up taking these green fuels, which also could be a little bit setback for the maritime, because where should this green fuel be used? But marine being so much in front, they are by far in front of having, you can say, a strategy for the future, how to do, which is important for anyone to make investments and have it all going on. There is about 170 different projects today. It is expected that about 2030, there will be at least 30 million tons of and biomethanol available. Then we have the blue methanol, where you are, for instance, you are producing with LNG or gas, and you are using also the carbon capture technology, and it will be available. It will be possible, you can say, to maybe even go up to 34, 35, looking at the different projects today. Some of the projects will not mature, and more will come. But this is what we expected so far. And that is a way to the, you can say, the goal of the CO2 neutrality using methanol. Thank you very much.
Thank you very much indeed. You've actually inspired a lot of questions, actually, which is good. And I'm going to field a few here at the moment. First of all, what is meant by e-methanol?
The e-methanol is you use an electrolyzer, and you are removing the carb and H from the water, and then you take you actually add to the system, so you end up with methanol.
Right. Okay. From an anonymous, Paul Marshall sent in a few questions. I'll ask one of those in a second. What are the challenges in respect of flag states' requirements for using green methanol as an alternative fuel?
I don't see the challenge for the e-methanol, or maybe the certification, because that can still discuss very much in the EU and also to a certain extent in IMO, because you have to be very sure, 100% sure, that if you call it a green methanol, e-methanol, or biomethanol, it is e-methanol or biomethanol, and it's not some kind of mixture. Because you have the molecule and it looks like exactly the same. So you have to be able to trade the whole process, the manufacturing and so on. And EU are very much reluctant to take biofuels from outside EU for the same reason. I think a lot of things will happen there. It has to happen there. But this is in process.
Okay. Paul has asked a couple of questions here. Can the fuel systems used for cryogenic fuels be adapted for the containment of methanol? And then he goes on to ask, what is the energy density of methanol compared to marine diesel? So do you want to do the cryogenic bit first?
Can I have that again with the cryogenic?
Yeah. Can the fuel systems used for cryogenic fuels be adapted for methanol?
No, not really. What you have for cryogenic, let's say we take LNG, you have minus 163 degrees and you have it as liquid. You need it as gas before it's injected into the engine. So what you do is that you evaporate it and you heat it up. You pressurize it in pumps in this unit, pressurize it up to 300 bar, and then it goes all the way from the external fuel gas supply system into the engine and is injected without being further pressurized. When you take a fuel gas supply system for methanol, it's very much like the fuel system for a normal fuel oil. You have a tank, which is at atmospheric pressure. You have supply pumps, which is about 25% more than the maximum supply. Or there's a bypass line, And then you have a circulating system. But a circulating system compared to the methanol and the diesel, you will say that the methanol go back to the tank itself. There can be some oil, and this is oil in the tank, and you have to take that out, and that is with the simple design of the system. But you cannot use the same systems for those things.
Right. Okay. And he also asked, what is the energy density of methanol compared to?
It's maybe a better way to look at it and say it's about twice the volume you need in the tank to be able to have the same power out. So there could be consideration in many ways about how to do that. But as methanol is a fuel at atmospheric pressure, you still have the opportunity to build the tank and build it into the hull in different ways, different shapes, which can be an advantage. If you have a pressure tank, as for LNG, it's much different, and you don't have the insulation as they have for the cryogenic systems and so on. So you say, okay, the tank is maybe 2 times more, but if you look at the insulation and all that, it's a different picture.
Okay. Just a couple more questions, and I will come back to the questions after Iain and Craig have given their chat. Now, maybe a stupid question, says the anonymous attendee. Are you allowed to use can you use methanol for auxiliary engines, but the main engines will be on compliance fuel?
Yes, in principle, you can do it today, and it's all about regulation. Today, we see much more PTO, power take off, actually put on the propeller shaft. And that means that you actually, when you are in service, then main engine on methanol is also producing electricity and taking over the job for the gensets. So they will be used much, much less. But that's another thing. But yes, you can do that, definitely. It could be that you start with methanol on the genset and say, okay, that's maybe a very good way to do, and I can use methanol when I'm in harbor, and when you're bunkering and debunkering or whatever you are doing there, and it can take maybe half a day and 1 day and so on. So if there's restriction on pollution in the harbor itself, it could be one way of doing it.
Yeah.
But it could definitely be that.
And then the list of, you talked about 120 harbors where methanol is treated. Is there a list of terminals worldwide where the methanol bunker stations are stated?
Yes, I have the list.
So you can get that from the Methanol Institute.
I can send it together with a presentation if you like.
Yeah, that'd be brilliant. And I'll send the presentation and that list on to all of the delegates. That's lovely. Oliver, John Sterling has actually said very excellent and honest presentation, which is nice. So that's good. And I know John as well. So Oliver has actually asked, where do you see the major bottlenecks today with implementing methanol as a fuel? Is it the supply chain?
It is definitely the supply chain. We need much more production facility. And again, the regulation need to be there. There need to be a common understanding that this is the way we should go before any decarbonization can take place. So yes, a lot of ideas, enthusiasm to go there, not only for methanol, but in general for green stuff. But it has to be helped by, you can say, authorities in the different ways. It will come.
And our very, very busy anonymous attendees also asked, what is the difference between blue and green methanol?
Yeah, the green will be, you use an electrolyzer, and as we talked about before, the electrolyzer will then be operated on based on alternative energy. That means clean energy from windmills, hydropower, or whatever you could say in that direction. Whereas with production of blue methanol, you will use gas, as you do today in part of the production of methanol. And that gas, you will also use a carbon capture in the system for the gas. So you will have something maybe 55 to 60% reduction. That means neutrality. So you will not go up to 100. But if we want to reach the target for 2050, then we need to use all the technology available. And that will be one of the things that we need to convince IMO and EU that this is something we need to do too.
Okay, Kjeld, thank you very much indeed, and thank you for the time being. I'm going to bring in Iain and Craig now, and big thank you to the delegates so far. Some excellent questions. Keep them coming in. We've got about 20, 25 minutes, but we'll no doubt make sure we can answer all the questions that you have. Can I hand over to Iain and Craig now? And I'll put myself on mute, but if you can share your screen, and I'll leave it up to you. If you can speak up a bit, gentlemen, as well, that'd be lovely. Thank you.
Yeah, thank you, Sean. Okay, hello everybody. We will start off then on our side with a little bit of information about the regulatory background for alternative fuels in general and methanol specifically. So given what we've heard from Kjeld about methanol, there is obviously challenges working with these type of fuels. And we started our journey off with alternative fuels on LNG, liquefied natural gas, which we started back in 2000 with the first construction of an LNG fueled ship. In doing so and learning lessons from building the first few ships, we realized that we do need some kind of standard and guidelines for producing those ships. And so in 2004, Norway proposed development of an international standard for gas-fueled ships. Fast forward to 2009, where the IMO adopted the interim guidelines for the safety of natural gas-fueled ships, natural gas-fueled engine installations on ships. And finally, in 2015, we came to the IGF code being finalized, and it entered into force in January 2017. The reason behind all these proposals and regulations was that you do need international standards to cover things like safety, construction standards, etc. So the purpose of the IGF code then is to provide an international standard for ships operating with gases or low flash point liquids as fuels. So the IGF code is like a broad spectrum of all the different fuels, but there are slight differences. Predominantly, the IGF code deals with LNG. And the basic philosophy of the code is to minimize the risk to the ship, the crew, and the environment, given due regard to the natures of the fuels involved. So those specific properties of LNG, methanol, and the fuels to come in the future. So the IGF code addresses all the areas that need special consideration for the usage of a low flash point fuel. And the current version of the code, as I said, includes the regulations to meet the functional requirements for natural gas as a fuel. So at the moment, the IGF code only focuses on natural gas. And given what we're talking about today, we can see that there are other fuels in use, so we need additional regulations. So the regulations for the other low flash point fuels will be added to the code as and when they are developed by the organization or the IMO. But in the meantime, for other low flash point fuels, compliance with the functional requirements of the code must be demonstrated through something called alternative design. Go on. And basically, alternative design allows a shipbuilder to deviate from the IGF code or to design a system for a fuel not specifically addressed within the code. So anything that's not LNG at the moment has to go through this alternative design process. And the key requirements of alternative design are that the proposed design meets the intent of the goal and the functional requirements concerned. And more importantly, it provides an equivalent level of safety of the relevant chapters. So any ship running on an alternative fuel should be as safe as a traditionally oil-fueled ship, or in the case of methanol or other future fuels, as safe as an LNG ship. And that brings us on then to the interim guidelines for methanol. So this is a specific set of guidelines for methanol as a fuel. And as you can see, these were introduced in December 2020. The guidelines for the safety of ships using methyl and ethyl alcohol, to give it its full name, as a fuel, provide provisions to minimize the risk to the ship, the crew, and the environment, specifically when using methanol as a fuel. So we're focused more so on methanol here, given that we haven't got the full regulations as part of the IGF code. It's again an introduction into the area. So again, the guidelines will mirror somewhat the LNG requirements in the IGF code. They will follow a goal-based approach. They'll specify goals and functional requirements for each section, and that will form the basis for the design, the construction, and the operation of the ships using methanol or methyl ethyl alcohols as fuels. And again, our overall goal here with these interim guidelines is to provide for safety and environmentally friendly design, construction, and operation of any ships running on methanol or methyl ethyl alcohols. The areas covered by the interim guidelines, again, they somewhat mirror what's already in the IGF code. You're going to look at areas like ship design and arrangement. Fuel containment system, as we've briefly talked about already. Methanol is somewhat unique amongst the alternate fuels in that it is a liquid at ambient pressures and temperatures, and as such, it can be stored in more traditional bunker tanks built into the ship rather than an independent tank. And as we've said, there are going to be requirements given that we are a low flash point fuel in methanol. So there's things like additional cofferdams required around the tank. And as we've already mentioned as well, methanol has less, it takes up more volume, about 2 times, so the tanks are going to be bigger. But it is a major benefit having those tanks built into the hull of the ship. As already mentioned, methanol bunkering is very similar to traditional fuel bunkering in that it is a liquid, but we have adopted some of the safety precautions used with LNG into the methanol bunkering system as well. Fire safety, again, is very important in all areas, but when we're dealing with methanol specifically, you have those unique characteristics of methanol as a substance. When it burns with a very weak flame. It's a lot harder to see than a traditional flame. It doesn't produce much smoke. It doesn't produce much heat. So it is quite hard to detect from our traditional fire detection systems. So that has to be addressed accordingly on a methanol ship. Ventilation, explosion prevention, always going to be very important. Again, especially with low flash point fuels, which do generate vapor when they're in use. Electrical installations is standard. Control, monitoring, and safety systems are always going to be an ever-increasing thing we find on ships as we advance technologically. And obviously, we have to cover the operation of the vessel as well from the perspective of dealing with a new fuel. That brings us on then to training of personnel, and this is where the IGF code training comes into play. It falls under the purview of STCW, an international convention formed back in 1978, in an attempt to standardize the maritime code by introducing a basic set of rules for seafarers worldwide. I'm sure everybody is familiar with the STCW code, being a comprehensive set of regulations established by the IMO to ensure that seafarers worldwide are properly trained and certified for their duties at sea. So it sets standards of competence for seafarers internationally. Specifically within that STCW code, you have Chapter 5, which is special training requirements for personnel on certain types of ship. And there is a wide range of vessels throughout the Merchant Navy fleet. So we do have certain ships which require extra training. And obviously, alternative fuels falls under that banner. So there is a regulation in Chapter 5 which covers the mandatory minimum requirements for training and qualifications of masters, officers, ratings, and other personnel on ships subject to the IGF code. And we split the training into 2 sections. First off, you have basic IGF. And that is on the screen there is the key phrase for who requires basic IGF training. Any seafarers responsible for designated safety duties associated with the care, use, or in emergency response to the fuel on board ship subject to the IGF code shall hold a certificate in basic training. So it can encompass quite a lot of staff on the ship. So officers, crew, anyone as part of a fire party, for example, will have to do the basic training. And again, that is mainly to understand the properties and characteristics of the fuel if you are responding in an emergency. The next level then is advanced IGF training. That's going to encompass masters, engineering officers, all personnel with immediate responsibility being the key phrase there for the care and use of fuels and fuel systems on those ships subject to the IGF code. So yeah, that requires some additional sea time for getting your full advanced certificate. You have to have completed at least 1 month of approved seagoing service, and that includes a minimum of 3 bunkering operations on board a ship subject to that IGF code. That has, in our experience, proved to be quite difficult because there are not that many ships out there to serve on. So there have been some bottlenecks there in getting those prerequisites before you get your full certificate. One of the things that helps with that is 2 of those 3 bunkering operations can be replaced by an approved simulator training as part of your advanced IGF course with a training provider like ourselves. There is, again, certain provisions within STCW that allow you to use your previous experience on LNG carriers to get an equivalence of IGF. So it is possible to get for a seafarer to gain IGF certification if you have LNG cargo experience. At the moment, however, the same does not apply to seafarers with methanol cargo experience. So this is something that you would look into modifying because, again, it is going to be hard to get the time on board until we have a sufficient buildup of methanol-fueled ships. So there are inconsistencies between LNG and methanol at the moment. We put this down to the fact that LNG is slightly more established as a fuel and a cargo. All these guidelines, the IGF code, the guidelines, the interim guidelines for methanol will be incorporated into the various class societies rules. So that's where your main information will come from when you are building and classifying a ship, and all the classification societies do this. So it's in their documentations to read. The last thing I want to mention, though, is flag state requirements. Specifically, this is something we found from the Isle of Man ship registry. They require an additional training over and above basic and advanced IGF courses that we've just discussed under STCW. So with the exception of LNG, as they state in their documentation, the IGF code cannot yet be considered to fully address the training requirements for the other alternative fuels that may fall within the framework of the code. So as things sit, completing the basic and/or IGF training allows you to sail on any alternative fuel ship. But in the absence of specific STCW training requirements, the Isle of Man have decided that for seafarers working on board ships using a fuel subject to the IGF code other than LNG, the seafarer should undergo a training of safety and awareness course specific to that fuel. So given that we're talking about methanol, if you are going to work on a methanol ship and it was registered with the Isle of Man, you would be expected to do an additional course over and above the IGF basic and/or advanced training. And again, you may see that being adopted by other class societies in the future. So I'll hand over to my colleague Craig to talk about a few of the projects we have done within SMT concerning methanol.
Yep, so following on from Iain, for us, SMT, last few years, it has been carried out a few training courses. First one we started out with was IAAPS, which is Institute for Advanced Automotive Propulsion Systems. And their target is they want to achieve, or they want to accelerate the transition to net zero mobility by collaborating with industry and academics to create zero carbon propulsion systems. SMT ourselves, we delivered a methanol awareness training program to IAAPS to aid their project in researching methanol as a marine fuel. The topics we covered during the course, all the properties and hazards of methanol and the methanol blends that come from it, Safe handling practices and use of appropriate PPE relevant to handling methanol on board vessels. Emergency response procedures, taking into consideration the likes of fires, leaks and spills. Although vessels already have procedures in place, things are quite different when we look at some of the alternative fuels. Gas detection systems and calibration requirements, being fixed gas detection and also personal gas detectors, and risk controls for ignition sources and electrostatic hazards. And lastly with them, they emphasised compliance with the IGF code, as Ian has already mentioned. More recently, we worked with Iain Bonehill over in Belgium. Again, they're transitioning across into alternative fuels. They're taking delivery of vessels within the next period of time, and they're moving on to a methanol base. Again, their content, core properties and hazards of methanol, being flammable, toxic, and the volatility behind it. Overview of methanol production methods, including the fossil-based biomethanol from the biomass and e-methanol from green hydrogen and CO2 capture, which has already been mentioned previously. The environmental advantages and regulatory context, going through IMO greenhouse gas strategy, the transition through the targets for the year 2050, and of course coming through the IGF code as a training. Guidance on safe handling, personal protection equipment again, and gas detection first aid, same as mentioned before. Key considerations for storage, bunkering and engine integration on methanol fueled vessels. And then more recently, we moved on with, of course, to Disney Cruise Line. Disney want to have the first vessel, or they will have the first vessel set to run on green methanol, being the Disney Adventure. And again, we delivered an awareness course to Disney Cruise Line personnel. They attended from different parts of the world, being shipyard in Asia where the vessel's being retrofitted, across to the offices in the US. The purpose of that one was to support the company's transition to methanol-fueled cruise operations, to provide part of the preparations for the conversion of the Disney Adventure. They bought the vessel from a Chinese outfit, the converting it across for methanol fuel, and they'll put it into service once they finish the retrofit. And Disney also have a plan in the future to build their vessels with a methanol fuel system, and I believe the next series of 3 could be based on that. Course content, pretty much just covered exactly what we've done for IAAPS and also Iain Bonehill. The last project we worked with, Lloyd's Register, their global client training team, they came to us and asked for us to help them provide a course based on methanol handling and bunkering, so it could enable them to deliver it to their client. That was for company directors, for port organisations, and anyone else who joined their meetings. The training we provided, again, same as other ones, the methanol chemical properties, hazards, environmental benefits, health and fire risks, flammability limits, and emergency response. Part of the delivery from Lloyd's Register was for port authorities, and although they have emergency procedures in place, they need to step that up, definitely if they're moving on to alternative fuels like methanol. The regulatory frameworks, IGF code, MSC circulars, MARPOL, and of course we incorporated Lloyd's Register rules because it was being delivered by Lloyd's. Safe bunkering procedures, including zones, control measures, and emergency shutdown systems. As already mentioned, bunkering of methanol is not any more complicated than normal oil fuel bunkering, but there are a few extra systems in place now for vessels where other vessels moving forward are not used to hazardous zones or emergency shutdown systems like we see on IGF coded vessels, and also moving forward onto these new methanol fuels. Overview of methanol fuel systems, tank design and dual fuel engine integration, and proper use of fire detection systems, gas detection systems, personal protection equipment, ventilation and inerting. Basically using nitrogen systems on board vessels to provide inert gas for systems like blanketing of tanks, double wall piping, anything like that. Material compatibility and coating requirements as per IMO and Lloyd's Register standards, depending on the tank material. Does the internal of tanks need to be coated? Anything like that. For the future, we have been a major contributor within a working group responsible for developing future training frameworks for basic and advanced courses on alternative fuels. That was inclusive of ammonia, methanol and hydrogen. We were involved constructing a framework, what needs to be covered for the basic and advanced, going from the simpler things through to what we cover on our normal advanced course, but breaking it down further on ammonia, methanol and hydrogen. Here is Stream Marine Technical. What we could offer: we offer training, consultancy services to support the safe and effective use of alternative marine fuels, including methanol. Of course, we do IGF training. We do the basic and advanced courses, covering all aspects of the IGF code. We cover basic training either here in Glasgow in our facility, or we also do the online training through webinars. Advanced training, 5-day course, will be done through here in our facility. Methanol awareness training provides a clear understanding of methanol properties, safety considerations, and its application as a marine fuel. As we've said, we've done for some companies already. Consultancy, we can help provide guidance for transitional vessels to alternative fuel systems, and of course, bespoke training solutions. We can customize courses tailored to meet specific operational and regulatory needs of individual clients. And of course, if anyone does require anything, you'd like to know more, please reach out to us at the technical@streammarinetraining.com email address. And of course, we'll be happy to hear from you and get back to you with propositions. And that is us. Thank you very much.
Okay, well, thank you very much indeed, Ian and Craig, and also Kjeld as well, a very, very comprehensive overview. We've had a number of questions coming in. I'm going to start to Ian and Craig here. What are the requirements for STCW for methanol fuel? Will the class and flag states impose more requirements by experience? But what are your thoughts? And Kjeld, maybe you've got a comment on that as well.
Fundamentally, you need the IGF code basic and or advanced training to work on any alternate fueled ship from the training perspective. As I said, you may find that certain administrations require additional training over and above that, but from the purview of the STCW, it is the basic and advanced IGF code training.
Yeah. Once you go into later on alternative fuels, the roadmap for the future training still to be determined. We might need to come through basic advanced IGF, and then additionally to that, fuel specific, being methanol, ammonia, or hydrogen in the future. So we might have to see clients coming through for both IGF and then moving forward into the fuel specific courses, which will be approved from the model courses developed through IMO, STCW, Merchant Navy Training Board, all the way down through us delivering the courses.
Yeah, so as said by Craig earlier, we worked on frameworks for individual fuels among various other institutions. It does look like the overall direction is to have training on an individual fuel basis, both at a basic and advanced level. So if you want to work on a methanol ship, you do basic and advanced methanol training. If your company then gets ammonia fueled ships, you would have to do basic and advanced ammonia training as well.
Okay.
I have one question, if it's okay. Yeah, okay. I would say it's the IGF code is extremely important, that's for sure. But where is the experience if we have not operated on a new fuel before? And it's just as an example, it took more than about 4 years before the IGF code came out after the first methanol engine was in service. And how could that be? Yeah, it's possible because if you have the flag states acceptance where it's trading, then it can actually be accepted. And in that way, we gain a lot of experience to be able to make the IGF codes. So it's like something which works together, and I think it's perfect. It's right, and so on. There's one thing I question, and that is when the IGF codes only or very much lean up to the LNG part, because LNG was first. Because there are so much differences we have, all of us have talked about between the operation on LNG and methanol. And there are still some of the things that is used, like ventilation volume, like tanks and buffer, what is called, the way the tanks are designed. And there are quite a number of things which could be made more simple when operating on methanol. But it has been LNG things which has been adapted because we didn't know better or something like that. Just a comment.
From a fundamentals perspective, I agree, Kjeld. It does make sense to separate the fuels out because they have vastly different properties. So from that perspective, I think our ultimate destination is to do individual fuel training. Given the progression of alternative fuels, we did start off, as you say, heavily on LNG, and that was the focus. And we do need to adapt over time.
Okay, thank you. Paul asked a question: what additional safety measures are required for a methanol spill within the confines of the machinery spaces? Who wants to answer that? Kjeld, do you want to answer that?
I think actually I'm not the best one to answer that
Okay.
part. SMT, I'm sure know much more about that.
From the perspective of a methanol spill, you have a couple of points to consider. Again, within those interim guidelines, it does require the use of a alcohol-resistant foam system on the tank tops of the ship. Given the properties of methanol, it's quite difficult to put out. One of the things you can do is you can dilute the methanol down, but it's still considered a flammable substance all the way down to 75% dilution with water. So one of the specific requirements is to have an approved a fixed firefighting system, but specifically targeted at the tank tops where ultimately the methanol and any dilution is going to end up.
If firefighting is having to take place because of a leak, as Iain mentioned earlier on, a very weak flame, visible flame, we can't see it very well, it's almost invisible. So thermal imaging cameras should be available on board either for fire teams or for permanently fitted inside machinery spaces or other hazardous spaces where you can keep an eye on the fire as you're trying to extinguish it.
Okay, thank you very much. And John Sterling asks, what are the construction differences between methanol and ethanol systems and the differences with the engine systems?
Yeah, if I could start, I would say, John, that there is, so far, we don't see any differences on the external fuel gas supply system because it's about the same liquid when it comes to, you can say, the volume part, the pressures. We expect it's the same pressure that will be boosted up on the engine, can be a little bit higher, but that's taken care of on the engine itself. I don't think that there might be something with sealings and so on that have to be investigated. But generally, there are a part of the maritime world that ask for ethanol. You can say shippers and operators around Brazil, for instance, or India, where they have a lot of ethanol. But there are a few tests I've heard about with Wärtsilä, and there's no, as far as I know, any conclusion or final design of the engines. My opinion is that there will be only very few changes on the engine itself. It could be the nozzles, the way it's sprayed in. It could be a little bit maybe on the pressure it's sprayed in with. These 500 to 600 bar is still in that area, so that might not be an issue at all. But we have to remember that all the engines have to be in compliance with Tier 2 and X6 Tier 2. That means also that there could be some necessary adjustment if you use a methanol system for ethanol. And my guess is that will be the injection equipment on board.
Okay, Kjeld, thank you very much. And just mindful of the time, and the delegates have been very kind to stay on a little bit longer. Probably just a last sort of training question here to Iain and Craig. Is there a specific certification for the one who trains the crew on board, or can this be done by the ship's senior management? And what kind of certificate was delivered upon completion of the training to Iain Bonehill? So, do you want to talk about the certification for the trainer?
I'm not 100% sure what they mean by training on board. Obviously, what we cover is the training for the individual people to qualify the individual personnel to work on the ship. If you want to do internal training, that would be at a company level. There is no certification to train people on board within the IGF code. You have to come to a dedicated facility like ours, or, as Craig said, do it via webinar. As far as Iain Bonehill are concerned, it was just a familiarization course for methanol. So they got an internal certificate saying they completed the training.
For the likes of the IGF code, our courses are audited, our courses are approved by MCA and Bahamas Maritime. In the future, when we get to the alternative fuel courses coming through, once that framework's fully published and agreed upon and published by the IMO, our courses again will have to be approved by flag states for us to provide the training facilities. That's anything on board after that. Yeah, you can give on-board training, as Iain's mentioned, but the actual, not saying the legality of it, but the approval behind it might not get picked up. It would get picked up by any flag state inspectors, port states, anything like that. So you'd have to go through approved bodies for the training.
Okay, thank you. I'm going to give Kjeld one last one from his friend John Sterling. This is John and the Kjeld show at the moment, I think. But sampling isn't easy for conventional fuels. Is it included in STCW, he asks? And methanol will have additional safety considerations. What are the specific differences in the sampling procedures?
Yeah, John, that's a very good question. To be quite honest, I don't know. I know that it's not easy. It's a low flashpoint fuel. It will not be easy to forward as we do with fuel oil. So it's almost like the labs have to be on the sides between where the ships are coming in. I really don't know that part yet. I think actually what I would do it was to, you can say, compared to fuel oil, where we have seen so many things in time and know that fuel oil is a combination of a lot of different products and you can say chemistry when it comes to it. Then the methanol is quite homogeneous, you could say. And then according to the specification ISO standard, there is standards for how and the way to measure it. And even before the ISO standard, there were standards and so on, industrial standards, not precisely for the maritime world. But it's a very good question, and I don't know what company like Maersk they do for their convincing that the methanol is okay. But the water content has, of course, an influence, and there is limitation for ethanol in methanol, also maybe more based on the ISO 821s, if that is changed and so on.
Brilliant. Well, thank you very much, Kjeld, and Iain and Craig for your time today. Massive thank you to the questions that have come through from the audience. Probably our best, most informed questions to date, really, on our webinars. Thank you very much indeed. As I mentioned right at the beginning of the webinar, that we have been taping it, audio taping it and video taping it today. So that'll then be available on the Ship Management International website in due course. I would like to thank you all. A great panel. You know your stuff. There's no doubt about it. I find it fascinating, broadening my knowledge of such things. It's a big issue at the moment.
Sean, sorry, but if there's questions we have not answered, could you send it to us? Then we can answer afterwards and come back to the ones who actually...
Exactly, I will do indeed. I'm just taking a copy of them now. So I think I've pretty much gone through all of them there, but I've taken a copy. And thank you very much indeed, Kjeld. I think he's going to make available his presentation, which I can then send to everybody. And maybe Iain and Craig want to do the same. That'd be brilliant. I'll make sure that all the delegates today get a copy of that, including the few that weren't able to make it. But thank you very much indeed for your time today. A fascinating discussion. Thank you very much. Thank you.
Thank you.
Thank you very much.